Yes, this is Dr.Senthil Kumar, Associate Professor, Department of EEE, SNS College of Technology. And this is the course Fundamentals of Electrical and Electronics Engineering, offered to first year, first semester. In the previous slide, we discussed about opto-electronic devices and the principle of operations. Now let me discuss in detail the constructions of opto-electronic devices such as LED, photodiode and PV cell. PV cell. Before going to the constructions, let me see the mind mapping of what the types of optoelectronic devices. It is an emitters and sensors and optocouplers, whereas the sensors is divided into two types. It is one is photodetectors and photoemissive, and in the photovoltaic again it is subdivided into two, whereas the photodiodes and phototransistors are classified into three, which is mentioned here. Now let me see the constructions of the LED first. Construction of an LED, which is represented here, which consists of two layers. One is P, another one is N. One is P type region and another one is N type region, similar to our PN junction diode, whereas the material is different. Which is maybe a gallium arsenide is included here. And the as per the previous slide itself, the colors depends on the doping, and the colors depends on the doping, and the colors depends on the doping level and the energy band gap. Here the two type layers, P and N type, and the active region is here. And due when the supply is given in forward bias condition, the recombination of holes and electrons taken place, and while recombining the holes and electrons pairs, it emits light. As per the construction, it is two layers, P and N, and an active region is consists of free electrons. The bottommost layer is nothing but the substrate. And while going to the photodiode construction, again the bottommost layer, which is called as a substrate, which is nothing but a cathode terminal is taken from the substrate, and the N layer is diffused in the substrate, whereas another P type layer is your blue color, which is diffused over the N type layer. When the P and N type layers are diffused, a depletion region is formed, which is represented in green color, a PN junction depletion layer, which is mentioned here in green color. For a photodiode operation, we know that it should be in reverse bias condition. Therefore, the terminals is taken from the silicon dioxide SiO2 diffusion layer, which is in the left and the right top of the N-type region. When lumens or a radiation occurs or placed in the P-type region, when a radiation or a lumens falls in the P-type region, the PN junction depletion region changes. You mean the conductivity property changes in the P or the N layer, or the resistance changes. Hence, the conductivity property changes. Hence, there is a recombination of holes and electron pairs in the PN junction region. Hence, there is a flow of current. The flow of current may increases or decreases, depends on the light intensity which falls on the P region. Therefore, this is the structure of a photodiode. And the third one is the PV cell, which is also called as a solar cell. Here again, the anti-reflecting coating is placed in both the top and the bottom layer, which is mentioned here in green color. Again, similar to our PN junction diode, here again two layers is there. One is p-type silicon, which is represented here in orange, and another one is n-type silicon, which represented in white color. The two layers are equally distributed. One is p-type and n-type silicon region, whereas the top and the bottom is coated with anti-reflecting coating, and the connection is taken from the nickel plating, which is shown in black color in the top and the bottom. And if, as per the principle of operation, it is photovoltaic effect. Therefore, if the light energy falls on the n-type silicon, which is in the top of the solar cell, which is on the top of the solar cell, when the light energy falls, a recombination taken place between the p and the n, or the conductivity taken place, and due to this recombination, the electrons electrons induces energy, and this energy is accumulated in a battery, or this energy is given to a load such that the load of the lamp glows. Thus, we have discussed the construction of solar cell, the construction of photodiode, and the construction of LED. And we have discussed all the principle of operation and the application of it also. Thank you for patient listening. Thank you.